Okay, welcome back, students. So we're going to look at factoring trinomials using the factoring frame here. Okay, so the first one we're asked to factor here is x squared minus 18x plus 17. So straight away, the sign pattern for this is negative and negative. So both of these numbers will be negative. I'm looking for two numbers that will multiply together 17. 17 is a prime number, so it must be 17 and 1, both negative. And that'll do me just fine because 17 and 1 is 18. So this is the most trivial case where 3 of the 4 terms involved in your two binomials are all monic or 1. So we go to negative 1 for one of them, negative 17 for the other, and we'll look at that expansion here, especially now when we're doing pen and paper, put these terms over in the margin, as you'll see in other videos and as you might have seen in class. However, we can confirm now that we're very happy that this gives us our middle term and that everything is fine. I'll leave the answer off in future. I might need to change the code around so the answer starts off. Turning on the answer here and checking it, we're happy, and we have a score of 1. We'll go on to the next question. Okay, again, they're going to be both negative. We're going to have a negative 1 and a negative 2. Okay, we can expand that to see that we do indeed get negative 3x on our cross products. Cross products is a cross between an x term and a constant term along the diagonal, because you obviously wouldn't multiply them from the same factor. And we can check that we got the right answer. Go on to the next question. Okay, now we have a mixed sign pattern, one positive and one negative, and the dominant of the two will be positive, or the bigger of the two will be positive. So I'm going to go with plus 3 and negative 1. We see that that does indeed work. We're on to the next question. Okay, let's step it up a bit. So now we have a trinomial now we can read here. So this is still somewhat trivial. It's a special case in that 5 take away 2 is equal to 3. Okay, what that tells me here is in terms of the subtraction is the 5 and the 2 will be on the same row. Not necessarily both negative, probably both negative. So in other words, this here wants to be x, and this here it's a mixed sign, so this here wants to be positive 1. Let's just check our expansions. That's like doing your margin and your cross product. So we'll get a negative 2x and a plus 5x. So that is not okay. Okay, because if you look here, this is the one we would put in a circle, and this is the dominant term, and the dominant term wants to be negative. So my sign pattern is the wrong way around. So I want this to turn into plus 2 and this to turn into minus 1. Okay, and now we have the correct sign pattern. In other words, we've made our dominant cross product have the same sign as the linear term. Okay. So now we have a situation here where we have a prime number here, a composite number here. The pattern is plus plus. And we're going to be splitting the 16. Reason we know that for sure is the other trivial trinomial would be this product. If I had an 11 here and a 16 here, and a 1x here, and a 1 here, then this would contribute 1x, and this would contribute 176x when you multiply them out, and this is not 177. And it is one of the other trivial cases. So the most trivial case, I suppose, is when they're all x's and 1's and there's only a sign distribution. The next trivial case is where 2 of them are not 1, not monic, and it ain't one of them. Okay, I know it ain't one of them because as I've already explained. So it has to be either 8 and 2. It's not 4 and 4, is it? Could be 44. No, so it has to be 8 and 2, both positive. We put 2 there and 8 here. Now I'll have to check my cross products 88. That ain't going to work because 88 is way too big. So I'll want to swap that to a 2. Sorry, this one wants to become a 2. Now that's 22. And this one wants to be an 8. And now we have our cross products. Wait, as I say, we're going to write them up here in the margin because that's what we always do. We want to leave here for the answer. What way are they doing this? Yeah, we might consider adapting this and then going with an extra line. Okay, but one way we have it sorted out. We've 11x and 8x and 2. We can check. We're happy with that. Next question. Okay, I'm just curious as to what makes, how difficult have I set level 3 to? Maybe just a mixed sign. I just try to see, can I go back here and keep looking at them? So what, no, they're mixed as well. Now that is trivial in that 11 and 3 is 14. 2 and 11 is 13. These are nice and easy. So generally speaking, 5 and 11 is 16. So these seem to be 2 number cases, if you like, 2 non-trivial numbers. Anyway, we'll go up to level 3. Okay, well that is trivial. This is very, very easy. It's 4 and 11 is 15. So you want to keep the 4 and the 11 together. And it's all positive, so it'll be 1s and 1s. So you get 11x and 4x. So that this occurrence with the 1 and the 1 here is like saying add the 4 and the 11 and you get 15. Okay, but here we're splitting this 16 because the only 2 things to check if it's plus plus is a sum for the middle or a product plus 1 for the middle. They're not happening. Okay, so I have to split my 16. Let's take 8 and 2 as a guess, if you like, and a 7 and a 1. And that isn't big enough. I need to put the 8 back for. It's not let me get 8. Oh yeah, that's 7. Yeah, I need to put the 8 here. 56 and a 2 here. Okay, 56 and 2x is 58x. So it works out very quickly on the tree by pen and paper. A tiny bit of trial and error, and you can check that it's right. And next question. Okay, so I'll leave this with you as a brilliant way to be creating questions where you get your feedback immediately, and you can it's called assessment as learning. You're learning as you go, and you know you're right because you've this immediate feedback. As always, students, I will see you in the next one.